how do I make a game, or how do I get into C++ game development? I get this question asked all the time, and so today I want to make a really fast game in C++, or in this case C. I've gone through many hurdles of setting up a really easy project. Believe it or not, C++. That's the biggest weakness of C++, the build system. And so I want to go over a very easy build system. Let's say you're on Windows, but you could even use this on Mac or Linux. And the first link we need is Visual Studio from Microsoft. When you're on Windows, you always need Visual Studio. And it's that link here on the left, by the way. If you click this, it's going to download a Visual Studio installer. That comes with the standard library. So basically it gives you all of the functions and a compiler for C++. For C++, you need to build a program using a compiler, and then that gives you the executable. Well, and that is what Visual Studio gives you. And then CMake, because it's basically like the industry standard. Every single library that you're going to interface with online will use CMake. You need to download the installer right here. I've already done this, and then you should have these two things. The only thing you need is Visual Studio, install that, CMake, install that, add CMake to the path, really important, and that's about it. You can get started with C++. For Visual Studio, what we need is game development in C++ if you're lazy. If you're not lazy and you wanna only use what we need for C++, you can uncheck everything, but we need MSVC, that's the compiler, the build tools, and we need the standard library, the Windows 10 or Windows 11 SDK. We need that too. I usually just remove the rest because it's a hefty installation, almost 7 gigabytes for Windows. That's the most basic installation of C++ that you can get on Windows. But at the end, we're going to explore this a little bit. I'm gonna show you different ways of building C++. And there's gonna be a really cool one at the end where we don't really need much to download and we can still build C++ using that. We don't even need, if you don't want to, Visual Studio. That's the cool thing. Anyways, but that's after the fact. We now wait until this is over. For CMake, basically all you wanna do is set up everything by default and add CMake to the path. That allows you to use it in the command line, which makes it very easy to set up your first project. Install and then just let it run. While we wait, it would be a cool idea if we just make ourselves a nice little folder. That is our My First Game. And then in this folder, we can already make some files. The first one is a CMake file to build the game. That's called CMakeLists.txt, and another file for the game, game.c. There we go. And yeah, I made a typo here. It's supposed to be called CMakeLists.txt. And then we open this up. We basically need to have a template that allows us to build the program on multiple platforms. Let's say you're on Mac and you want to build this game. Then you should be able to do that with this CMake file. And so much so, if you're on Windows, you should also be able to build this game with this exact same CMake file. And yes, I'm using Notepad++ for this. If you don't have it, you can just use the editor. It doesn't really matter. The editor makes it a little bit more annoying to type CMake stuff because Notepad++ has a little bit of CMake support. And I'm gonna paste a bunch of code in here, and I'm just gonna explain what that is. Basically, CMake, in my opinion, the less CMake you write, the better. Because it's ultimately just going to be a, well, let's call it wrapper around or above C++. The way C++ works is you have a compiler, you invoke that compiler, that is usually a program, and that then takes in a source file, which in our case would be the game.c file that we created, and that is then built using that compiler and certain options. And CMake hides this away so that we have a cross-platform solution because these specific compiler commands vary between platforms. And so the CMake file, in my opinion, the less we use it, the better. I'm gonna quickly go over what we want. We just require a certain version. This is always needed for CMake. This is a very old version because we don't do much. I'm making a game in C. If you want to make a game in C++, you can also set the CXX. Yes. For C++, it's XX, not ++ or PP, okay? CXX standard, and then you could say, well, 20 or something, whatever you want to do. And then over here would be CXX as well. Just wanted to add that for completeness sake. We're going to do a C game, though, because I think C is cool. And I'm just going to leave it in here with comments if you want to do a C++ game. And then what we do here, we are going to download Raylib if we don't have that available, because just like C++ and the compiler, Raylib also needs to be compiled. It is just a C++ program to a specific platform. So if you are on Mac and want to download Raylib, you download a different version than if you're on Windows and you download a different version there. So what this code does here is just download Raylib into its CMake folder and then use that proper version to your platform where you're developing on. It's just making it a little bit easier to get started with Raylib. And then at the bottom here, we're just going to create an executable out of one source file. In my opinion, we don't need multiple source files for a small game. If you want to get into game development right now, use one source file, make the game in the source file, and just learn. This is for you to learn game development. You don't need fancy setups. It's absolutely not needed. The developer of Undertale has written the most atrocious code ever, and he's massively successful. You don't need it. Don't overthink things. That's the most important part. And then I'm just gonna quickly go over here. We are linking with Raylib. That's essentially just giving us the source code so that we can call the functions from Raylib. And then we are setting an output directory. Because what I like is when you have a folder here, I would like to have a setup where we have assets. The source code maybe here or in a source folder, that's up to you. You would need to include that. And then the executable right next to this. Minimum setup, nothing fancy, just very easy. And so here the assets, we're going to add a picture really quickly because we don't need that in the future. It's taken from another example that's basically just a cute little image that we're going to use to showcase how we can load textures using Raylib. But yeah, now that we are done with this, Visual Studio should have been done, which it did. Then it's gonna give you this window right here. Once Visual Studio is done installing, this is what it should look like, and then you just close this out and you're done. We're gonna skip the sign-in for now because we don't want to make a Microsoft account, and I like the dark version of Visual Studio. It's easier on the eyes. And then we're just gonna start it. Now, we're not gonna do anything with this yet, because first we have to set up our CMake project, and that's a bit easier if we do this in the command line. So if we go back here, and we type in cmd, since we have installed CMake already, we should be able to call CMake. There we go. So CMake is there, but we didn't supply any options. And so the first thing that we need to do is we now need to build a project with CMake so that we can, for example, start Visual Studio or something else. We need to call CMake -s dot. This is where to locate the CMake.lists file. In this case, the dot operator means in this folder. -b, and that would then be the build folder. This is where it's going to put all of the build files. And it's going to generate a lot of files. It's also going to download, hopefully in this case, Raylib, which right now that should take a lot of time. And so I'm going to skip until it's done. Okay, now we have written the build files to our build directory, and we can take a sneak peek here. And this is what I wanted to do first. We now have a game solution file, which allows us to open up Visual Studio. But we want to build it too. And so how do we build this game.c file, which by the way is empty at the moment. There's nothing in there. I have actually written a small little example project so that we can get started, and I'm gonna go over like the basic Raylib stuff to get started in game development. So I know this is copy-paste, but bear with me here. It's a very, very basic setup where we just include Raylib, open up a window and stuff like that. But I'm gonna show you this in Visual Studio, because now with this game.c file in there, we have a main function. This is what we need. And we can now, if we wanted to, build the game. And building the game is as easy as calling CMake --build. This is where it tells CMake to where to look for the build folder. We're gonna supply the build folder here. And then it should build Raylib once, only one time, because we downloaded the code. We need to build it for the platform and then build the game, which it does. We have two warnings here, converting float to int, but now we should have a working game and executable, which is right here. And this is what we should see. And it also shows us this. It opens up on my other monitor because that's the primary one. This is how fast you can get into Railip. And the cool thing is now we can go into the build directory and open up this game solution file. So this is what it opens up. And the Solution Explorer is always to the right when you install this. I like it on the left. Over here we have our game. Don't worry about these. This is our game project. And if we see the source files, this is where the game.c file is located. We're going to make a game in here now, because this is Windows and Visual Studio is the fastest way to get started. If you want to use another editor, maybe another compiler, we're going to do that too. But at the end, we're going to download Clang and Visual Studio Code, because for me, Visual Studio Code is the best. I can use it on Linux, on Mac, on Windows. It's really cool. So we're going to do that at the end and then also invoke the Clang compiler so that you can see what you need to do, what CMake is doing for you. Because right now it's just this black box. And I think when you get into C++ game development, maybe you want to start writing code as fast as possible. Okay, now we can start writing code already. We can already make a game. So Railip, right? Very simple. We have init window. This is just taking in a width and a height and a title, and we already have a window. Boom, that's creating our window. We can load textures. Very easy. We can set a target FPS. Then we make a very simple loop. If the window is not closing, we begin and end drawing. Very, very easy. We can draw textures, we can draw text, we can draw many things. This is ultimately all you need to begin a game. And that's what we're gonna do now. The first step we should do for this to work is set it up as a startup project, the game, then go to properties. We need to go into debugging and then set the working directory. The project directory is here in build. That's where Visual Studio operates at the moment. We want to operate in this directory here because this is where the assets are. So what we need to do here is just add / ... go one above directory. Windows. Don't ask questions. It's Windows. You can do this different ways too, but this is the easiest way. Now, if we press F5 here, we should see the same result. There we go. So now we can see the asset. It works, and we can begin. Let's make a game. Okay, so I moved the Solution Explorer to the right and make myself a bit smaller so that you guys can see the code better. And so in order to make a very simple game, I always start with a type def, since this is C, struct for data, game state. And in the game state, we want to move a player, of course. The first thing and the funniest thing, or the most interesting thing, is to move a player. That's where everyone should start. And so we need a vector to player position. And in order to change that player position, we need to have a game state on the stack right here. So we're going to put game state initialized to 0 on the stack. There we go. And we can now already change the player's position if we wanted to. But I'm going to quickly add a couple more fields, floats for the size of the player and another float for the speed of the player, so that we can change those later. And I'm also going to generate a game state default state because we need to reset that later to the default state when we, let's say, lose the game or restart the game. And that is just going to be a player position of screen width divided by 2 and screen height divided by 2. There we go. And then the player size by default, that is going to be 20 pixels. And then the player speed is going to be 50 pixels. Now these values are chosen arbitrarily. It's essentially making the player, later on the player will be a bit faster than the enemies and the player will get faster the more enemies we kill. That's essentially the idea. And so that default state needs to be static, const, otherwise C is going to complain. Now that we have a static const default state, we can assign that to the game state. That's now our default initial state. And now we want to move the player, of course. Let's get rid of this code here to draw the texture and the text. We're going to do that later. We want to clear the background to black now so that we can see the player a little bit better. And now I want to move the player. And I usually like creating these local scopes because that allows me to section my code a little bit. We can also use folding later on to turn this into like a locally scoped function. I like that a lot. You could also make a function if you want to, but it's just as simple as here's how you get input. Key is down. Key A. Okay, that's moving the player to the left. So that is game state. dot player position dot x minus equals game state dot player speed times the frame time. Get frame time. We have a screen to the left. Up here we have the game, and to the right we have the renderer. And in a usual loop we have the game generate data for the renderer, which is what the renderer needs, so that it can transform this data to the screen so that we have a picture. That is called a frame. And then once the frame is fully drawn, which is usually done using vsync, and then the game can continue and update itself, which then would supply more data to the renderer, and the renderer would draw us another frame. This is usually what we call frame time. This frame time in our example, now there's a little bit more going on, but is 1 divided by 60, which means 60 frames per second, or 0.016666 seconds per frame. So 60 frames are happening every second, and this time is useful to generate more deterministic values when it comes to speed and updating the player, which is why we need that in our calculation for the player's position. Otherwise the player would move faster or slower depending on the target FPS, and so we want to be deterministic over time. There's more that goes into this, of course, but this is the very basics, and you don't need to know much more in the beginning. This will come with experience. And we need to do the same thing for all of the other directions. So to move the player to the right, we make the X value increase. To move the player up, we make the Y value decrease, because Y is negative when it goes up. And if we want to move down, we increase the Y value. And that should already move our player if we build the game. But we are not drawing the player yet. So Raylab offers you a lot of draw functions. So for example, for the player, I want to draw a circle. That's very simple. It just takes in the center X and center Y, radius and the color. So for us, that would be game state, player position.x, game state, player position.y. The radius, that would be game state dot player size, and then for the color that would be green. There we go. And now we should have a moving player already. We have a green dot here, and we can move in random directions. That's already basically like a small little game, and that's really quickly, right? Wow, yes. So now we have a game. Now we can move the player. What should the player be able to do? In my opinion, the player should shoot some bullets, right? And so I want to make the player shoot bullets. How is that working? Well, I want to have some sort of timer that increases over time so that the player can shoot bullets. And that is another thing that we're going to add to the game state. That is a, what should we call that? Shoot delay. That's how often we can shoot. And I want to have a float shoot time. This one is what increases every frame, and if the shoot time reaches the delay, we can shoot. And so by default, the shoot delay, I set it to 0.3. I tested this before. This is a reasonable shoot delay to have. So we basically shoot 3 times a second. And the way this works is, if our game state shoot time is less than the shoot delay, then we want to add delta time to the shoot time so that we can shoot whenever we have enough time. But we want to make it so that whenever we have reached the shoot delay, so that we can shoot, we don't want to have the shoot time increase further, because then we would be able to shoot 10 times in one click, which is not what we want. We want to only shoot once if we haven't shot in a while. Essentially, that's what this if state is doing. And then we just do game state dot shoot time plus equals get frame time. And then over here, instead of an if, we do a while loop. We don't have to, but I like doing that because we could potentially shoot multiple bullets if the frame time is high enough. While our shoot time, game state shoot time, is greater or equal to the game state shoot delay. This is when we want to spawn bullets. What is a bullet? Well, that's where we need to generate another structure. A bullet is another type def structure. Projectile. And this projectile needs a vector to position, a vector to direction, so that we know in which we have shot the projectile. And then I also like adding in a float speed, which we can put it here too, because ultimately what I want to do later is increase the speed of the projectiles the more kills we have, and increase the size of the projectiles the more kills we have, and maybe give it some piercing. So we can have some like global data here that says, well, if our kills are 50, then the projectile it flies 10% faster or something. So we could have a projectile speed here, which gets set to the projectile when it gets created. And then we also have a float projectile size, which is also getting set when the projectile gets created. So then we have a float size over here. And then we also can have like an int projectile pierce, which allows it to hit more enemies and then kill them. That would be an int pierce counter. And so by default, we need to set these values. And this is projectile, not porch. Projectile speed. Oops. That will be 100. The projectile size will be 4. And the projectile pierce, well, it will be 0. So we're going to omit this. Omitting means the default value will be 0. Now that we have these set, we are able to generate a projectile if the array of projectiles is not full. So we now need an array of projectiles, and we're going to put that into the game state too. So we need to have an int, projectile count to monitor how many projectiles we have in the array, and then we need a projectiles array of max projectiles. Now this is a constant. It looks like I forgot to add a projectile on the projectile struct. Let's add that here. Okay, so now back to projectiles, we need to add a max projectiles define, which that has to be done in C, max projectiles. That would be, I'm just going to add 100, and since I know we're going to have enemies, I'm also going to add max enemies here too, and that will be 100. So 100 projectiles and 100 enemies. So might as well just add the enemy now, because the projectiles, they will collide with the enemies. Type dev struct enemy, and the enemy will just have, the enemy will just have a vector to position and a float size that can be used for collision detection later. And let's not forget the enemy here. There we go. And we can also already add the enemies to the game state, so we don't have to go back enemy count, and then that will be enemy and enemies, and then max enemies. There we go. Cool. Now that we have the game state all set up, let's go back to actually shooting projectiles. That's here. So whenever we shoot, first we need to make sure that we don't already have an array of 100 projectiles present. If the array is full, we cannot shoot a projectile. So what we do here then, if our game state dot projectile count is greater or equals to max projectiles, then unfortunately we just have to break out. We need to wait until a projectile disappears before we add a new one. And that will be then this, a projectile or proj is defined by these things. We need a direction, we need a position, we need a, I think it's size. The position is very easy, that's just the game state's player position. The direction is a little bit more complicated. We need to fire towards the mouse, and this is where we need to add one more library that also comes with raylib. We need to have some sort of math functions for the vectors. By default, raylib does not come with math functions, so include raymath. And that is still not enough. We also need to define a raymath implementation, because then the raymath and raylib, they will include the implementation for the functions. So what we can do now here is this. We want to generate a direction towards the mouse. Vector to direction is, we want to vector to normalize, a vector to subtract from And this is where, okay, let me think. We want to go towards the mouse. So the second one is go towards. Yeah, so from the player position towards get mouse position. We want to shoot a projectile towards the mouse position. And we need to normalize that because otherwise the direction would behave weirdly. And then the size is just the game state.projectile size. There we go. And now that we have a projectile, we can just add to the game state projectiles on game state.projectile count ++, increasing the count, adding in the projectile. There we go. That's all we need to do to shoot a projectile. And I'm gonna put this into a local scope too. Shoot projectile. Add all of this thing in here. And then make sure that this is moved one more to the right. And for those of you who are wondering, 10x programmers, they come from the level of indentation that you have. Okay, so what we have here is the first level. That's the int main void. The second level, that's the while loop. 2x programmer already. Then the third level is also the while loop, but you know, our local scope. And now that I noticed, shoot projectile should not be in move player, but it should be here. There we go. Okay, that's the third level. And then we have the fourth level here. So we're already a 4x programmer. Just saying, you know. And so yeah, we can now shoot projectiles. But we also want to show them, right? And this is where we do this here. Update projectiles. We want to do a simple for loop. Int proj index is 0. Proj index is less than max. Oh no, that is state.proj count. Index ++. There we go. We get the projectile. Pointer proj. From the address of the game state dot projectiles on the proj index. And right now we're just going to make the projectile fly. So how do we make that fly? We do proj.position.x plus equals the proj.direction.x times the proj.speed. And then again, multiplied by the get frame time again, so that we only move deterministic over time. It's not 100% deterministic. This is where fixed time steps come into play, but this is going to be a very simple game, so we don't go into this right now. And then we also want to draw it. Well, we have projectiles in the game. We can make them fly into the direction we want to draw this. And this is where we draw another circle on the position of the projectile. So projectile.position.x, projectile.position.y, and the radius projectile.size, and then that would be a color of yellow. Let's see if this works. Might have done a mistake. Over here, and it is shooting projectiles, but they don't move. Okay, must have done something wrong here, but this is where we can debug. Ah, I did a classic. I forgot to decrease shooting. So essentially, since we have shot a projectile here successfully, we also need to set the game states, the shoot time minus equals the shoot delay. There we go. That's a classic, and it looks like we are not doing a proper direction here, which actually it should. Let's see here. Maybe that was just a mistake. No, it's not. I've not encountered that before. It's just placing dots and not supplying the direction here. I wonder why. Nah, I forgot the speed. Yeah. So I did forget the speed. That's why it didn't move. The game state dot projectile speed. There we go. And now we can successfully move. And it looks like I did the classic. Always the wrong way. So we need to exchange the mouse position and the projectile position, because it now shoots in the opposite direction of the mouse. Nice. Okay. It's always the same. I don't know how many times I have to make that mistake, but it's fine. Game state dot player position. Love it. Okay. Now that the projectiles can fly, we need enemies. We need to kill enemies, of course. This is where the enemies come into play. And also, I want to only shoot projectiles, by the way, if the mouse is down. So mouse, if a mouse button is down, and that would be left mouse button. There we go. We want this part here to be in front so that we only spawn a bullet when we actually press the mouse button. I think that's a little bit more player involved. And you see how easy this is? We just added in this. We don't have to worry about anything. We can open up a window, we can get input, and we can even do a sound. And we could even do, you know, some bullet effects as well. Really cool. But for now, we should have the bullets spawning, and we need enemies to attack and enemies to run towards us. So that would be enemies at the very bottom here. Update enemies. So first we need to spawn them. How would we do that? We need a const float spawn frequency. And I usually like to set this to a second and then make that be more depending on how far the game is advanced. For that we need some sort of game state game time. That increases over time, of course. And I usually like to set that to, I don't know, a 1/10 of the game time. So 10 seconds would mean... wait a minute. Am I doing this correctly here? We need to divide one by a high value here. And I basically do this every 10 seconds. This gets halved. Correctly? So we have game time 10. 1 divided by 1. So after 20 seconds, we should be at a spawn frequency of 0.5. So that would be divided by 10. We need that game time. And we're going to add that to the game state too. And then increase that in the loop. Let's see here at the very top. Game state now needs a game time. And I usually like to put this at the top. Float game time. And of course, by default, it's 0. So we're not going to do anything here. And whenever we are running our loop, we do game state dot game time plus equals frame time. There we go. Now that we have game time, we can make the enemies spawn more and more over time. Now that we have the spawn frequency, we also need a spawn timer. And that is something, we can put it here, but also in the game state. So game state, spawn timer or spawn time plus equals get frame time, and we need to add that too. So that we can spawn enemies over time. Let's put a section here for the enemies. That would be a float spawn time. And then here back at the bottom, now that we have the spawn time in the game stage, we can just do while the spawn time, the game state spawn time, is greater or equals to the spawn frequency. We want to spawn enemies. And here we use the same trick that we did with the projectiles in the loop when we spawn them. If we don't have enough space in the array anymore, we need to unfortunately break. So we can only have at most 100 enemies on screen. So that would be enemy count and max enemies. We have to break here. If not, we create an enemy at a random position. And this position, in my opinion, should be outside the screen. And it's actually very easy to do that. We start out from the player's position and generate a random value between 0 and 360 degrees. And you can see that this goes into a circle, right? We want to spawn around the player in a circle. This is degrees, and we can multiply that by pi divided by 180 to get radians. So that would be a float radians value, which we can then use to feed into the position. So we start out from the game state's player position on X, and then we add to it the... actually, we get the direction for this first. I think that's a little bit easier. Vector 2 direction would then be the cosine float from radians and the sine float from radians, which generates... this is a normalized direction, and that's not a vector, but a vector 2. Now that we can use that direction and multiply that by a certain minimum distance. And that for me, the very simple thing here would be to just multiply that by the screen width, not height, divided by 2. That would be the distance. I guess we can do a const float distance. Here that would be screen width divided by 2.5. And then we can just use distance to make this a little... Oh, great! What did I just click? And then we can use this right here to make this a little bit easier. Distance. And then we do the same thing for the game state dot player position dot y plus direction dot y times distance. That would be our position. I think that works. And then we need a size. The size for the enemies is basically like this. Over time, I want the enemies to get bigger to make the game a little bit more difficult. So I want to generate another const float enemy size that starts out with, let's say they are 8 pixels big. And then over time, I want to multiply the game state's time in there. Let's say divided by, I don't know, 20. So over 20 seconds... Or we can add the game state time to it, right? So after 20 seconds, they are now 9 pixels tall. We could also make it so that the enemies get smaller over time. You know? Get smaller over time, which makes them harder to shoot at. I think that's also cool. Like, that's up to you. So that's programming the game already, you know? That's the cool thing. We are already programming the game. So that would be... the size would be enemy size. Just want to quickly chime in here. If we set the enemy size to be minus the game time, then unfortunately at some point we are going to reach less than 0 size. So the enemies are actually invisible and maybe have a minus size, which I actually haven't tested because I didn't get that far. So there could potentially be a bug in here. But, you know, you're going to figure that out yourself if you even get that far. Just wanted to point that out so that you might not run into issues and wonder, well, what's happening here? There we go. And that's it. Then we're going to add the enemy game state.enemies on game state.enemy count ++. We add the enemy there. Okay, so if I didn't do a mistake, which obviously can happen, we should now have a really nice spawn system for enemies, and we need to make them move towards the player. And this is where we quickly make an update function, and then we already should have enemies walking towards the player. Update enemies. In here we also do a range-based for loop. Int enemy index is 0. Let's see. Game state.enemy count. Enemy index ++. Enemy is the address of game state.enemies on enemy index. Okay, we grab ourselves the enemy from the loop. That should be very basic by now. And now all we need to do is change the enemy's position based on the direction. So plus equals some sort of direction towards the player, multiplied by the enemy's speed, obviously multiplied by the frame time. And so how do we get that direction? That's another thing where we have to do a vector to, where we have to do a normalize. So vector to normalize. Using a vector to subtract. And this time we're gonna get it right. 100%. Let's see here. The direction is from the enemy to the player. So the player is the first thing in the thing. Because we want to go towards... No, the player should be the second thing in the game, in the thing. So first we have the enemy position, right? And then we have the player position, correct? Because this is totally... gonna work this time. Right? Yeah, it's gonna work. And now we just need the enemy's speed. That's another constant that I want to increase over time. And this is how I'm going to make the game more difficult over time. Just by adding in these small little scaling factors. And this is basically gameplay. What we are doing here, enemy speed, this is what you come up with. This is where you make the game. We could have a fixed game speed, enemy speed, but that would be boring. Making the games faster, maybe smaller over time, and tuning that, that's gameplay. And that's awesome, in my opinion. So we could start with a game's enemy speed of, let's say, 40. So slower than the player. But we're going to remove the game state's time. Let's say, how fast? Every 10 seconds? We want to add 1 speed? Or we remove? Wait, actually that needs to be plus. Sorry, plus. So every 10 seconds they get 1 faster. Or maybe every 5 seconds. I think every 5 seconds would be too much. Let's try every 10. This is balancing. We'll have to test this, right? And yeah, now that we have the enemy speed, we also need to draw them. And of course, this is where... Actually, let's do that. This is where Railib comes in again. Draw a circle. And the same thing. Enemy position.x. Enemy position.y. Enemy size. And then color. And that's just going to be red. Enemies are red. We could test if this works. If we didn't do a mistake, we should now have enemies moving away from us. Cool. And we also did the same thing for the spawning system that I did with the bullets. I always forget this. And it's good to run into this because, you know, seeing these problems happen, probably going to happen to you too. We need to do GameState.SpawnTime minus equals GameState.SpawnDelay. Or the spawn delay or spawn frequency that we have here. So spawn frequency over there. So that we only spawn 1 and then move on and wait for the next one to spawn. And of course, I made another mistake. I don't know why I keep doing this. So essentially, the first thing in the subtract is where we want to go to. So we want to go to the player position, comma, from the enemy's position. Okay? Easy. It's gonna work now. Which it does. Cool. And now we just need... that's actually a lot. That's too many. That's too many! No! So yeah. And now we need to program the enemies touching the player. When an enemy touches the player, the game is over. So, you know, touch the player equals game over. How do we do this? Very simple. If we have collision circle, we are checking for circular collision. That is very simple. We check the enemy's position against the game state's player position. Not the player size, the player position. And we need to have a radius for the enemy. That would be the enemy size against the player size. There we go. And if we are colliding, then, well, at the moment, we're just going to do game state is default state. So no, not default, default state. We're going to reset the game state to the value that it was at the very beginning, resetting everything back to 0. And so now we should already have a lose condition. This is essentially the lose condition. Let's see if that works. If an enemy runs into us, it should just reset. Which it does. Cool. So now that we have a lose condition, let's quickly fix the spawn frequency. I think I'm doing something wrong here. Okay, so I made it like this. Every 10 seconds, the enemies half in frequency, essentially. And so they start spawning faster like that. Okay, cool. Now we need to add collision. We have collision for the enemy, but we also need to collide the projectiles with the enemies. So this is where we do that here. Collide with enemies. And since we already have the enemy loop, that makes it a lot easier. We can just copy this over here. And then every projectile will always look for enemies to collide against. So what we do here is we check the same if check if collide circles from the check collision circuits from the enemy position against the enemy size using the projectiles position and the projectiles size. There we go. And if we have a collision, then of course we want to kill the enemy. And that's very simple. The way we kill an enemy is basically by just copying over the last enemy into the enemy slot. And that's actually done really easy. We set the value of the enemy to the value of the game state dot enemies on the last. So that would be game state dot enemy count. And we can't do count, but we need to do minus minus count. So what does that mean? We set the value of the enemy, so the data, to the last enemy. And the last enemy is, if we have 2 enemies, our index into the array would be 0 and 1. So count would be 2. We're going to decrease that count to 1. Now it indexes into the last enemy. And then we're going to overwrite our first enemy with this. And since we have now decreased the counter, we are now going to index. We have 1 count, right? And we're indexing into the slot 0 the next time we run this loop. Which means you might be thinking this minus minus could go and turn the enemy count to 0, but that's not true. It could turn it to -1, but that's not true because we only go into this loop if our index is less than our count. So the moment we are in this loop, we are guaranteed to have a count of at least 1. So the moment we decrease the count back to 0, we're still removing 1, but nothing happens. Okay, so that's essentially just replace with last enemy. And then we need to obviously break out of this loop. Because we have now killed an enemy. We don't want to look at more enemies. And this is where we need to make a decision. Since if it's a normal projectile, then all we need to do here is check. We need to delete the projectile essentially. If projectile pierce is less than 0, then we do the same thing, replace with last projectile that we did with the enemy. So the value of projectile is GameState.Projectiles on minus minus GameState.Projectile count. So we replace that with the last projectile too. And then we no longer draw the projectile, which means we're actually going to do this here. We're drawing the projectile here. And this is the last thing in the loop, which means since we have now decreased the projectile, the next time we look at a projectile, it will be overwritten. So basically the same thing, replace with last, replace with last. And the cool thing is, here, this is where the scaling happens. This is scaling the game. But we're going to do this after we have checked if this actually works. Can we kill enemies? Can we remove projectiles? Let's see if this works. And so in order, every time we hit an enemy, the projectile needs to set a pierce minus minus. So we have just pierced 1 because that will later be something that we can scale to make the game more interesting. And so let's see here. This will now hopefully work if we did everything correct. Let's see if enemies are... Where are the enemies? Are you running? There we go. Let's see if I hit this guy. He disappears. And the projectile disappears too. And so this quickly turns into a game where you have to be very... Oh god. Oh my god. There's quite a few spawning here. Yeah. We need some... Yeah. So we need to be fast here, bro. Alright, yeah, some more and more, but so far it's good. Yeah, okay. Yeah, I get it. So this is like Ozu, right? Oh god. But a little bit more... Uh-oh. Okay, yeah. Yeah. The enemies also get smaller. Yeah, that's fine. Totally fine. Okay. So now that we have this, we can scale the game to make it more interesting. So for example, and this is very easy. Every time we kill an enemy, we're going to increase a kill counter. ++. So we need to add that kill counter to the game now. This is the one stat that we're going to track. Let's see. Int kills. By default, that will be 0, so no need to be there. And so what do we do whenever we kill something? This is the scaling part. It's very simple. We just check if the game state.kills modulo a certain value is 0. So for example, every 10 kills, I want to increase my projectile speed. So game state.projectile speed, not size. We could also do size. Plus equals 1. No, 10. 10. Speed of 10 is better. So now every 10 kills, I get 10% more projectile speed. Or 10 flat value of 10. Okay, and on 15, And these are just some arbitrary values. You make them up yourself. We could do projectile size. Let's increase the size of the projectiles by 1. What else could we do? We have 20 or maybe 25. What else could we do here? We have... Oh, what about shoot delay? Let's make it so that we can shoot faster. I want to... So by default, shoot delay is 0.03 or 0.3. What if we do minus 0.05 maybe? Or we can multiply this. We can do minus, which effectively would turn this into a minus value. So we have to be careful, but I don't think you can survive that long. Yeah. What else? What else do we have here? Maybe every 30 kills something. Every 30 kills. What else do we have here? We have game time, kills, player position, player size. We can increase the player size as well. We have projectile speed, projectile counts, pierce. What about pierce? Projectile pierce. That would be something we increase by 1. Let's say every 30 kills. Okay, and I also want to do something to make the player worse. So this is debuffing the player or making the enemies bigger. So for example, every 12 kills, the player size changes by 2. Now we get bigger and it's much more difficult for us to escape the enemies. And so this is, by the way, where the gameplay stuff happens. This is the balancing and fun stuff. Negative, shoot, automatically take another shot in the past. Shoot, automatically take another shot in the past. So let's see how that feels with the scaling in the game now. All right, let's see. I'm just gonna fire randomly until something appears. Yeah. It's easy so far. Yeah. Very easy game. Did I increase in size yet? I feel like the enemies are also getting smaller. I don't like that. The enemies are getting smaller, bro. Come on. Okay, I need to make the player better, I think. All right. Okay, so... But this is not interesting enough yet. What we can do here, and this is what we copied, or not copied, this is what we commented out at the beginning. We can draw texts. So for example here, in the game, we can also give ourselves a kill counter. Over here. We can draw a text. And this is, I guess, let's call it kill counter. That is not a char pointer, but in this case we need to have a character array of, let's say, 100. And then this is just initialized to 0. Okay. And then we need to do a sprint F into the kill counter using a format string, which is just says kills and %d. And then it sets the game state dot kills in there. Puts the game state dot kills in there. And then this right here is basically getting the size of the text and trying to center it. And we're going to draw a couple more texts, which is why I want to make a quick text function, void draw text centered. And then it just takes in a const char pointer text, a vector to position, and then I guess a float font size. And then it essentially just does... It's like a wrapper on this function to make our lives a little bit easier. So the text size over here, we can set that to this. That would take in the text, the font size here. And then we need to make sure that the position.x is minus equals the text size .x divided by 2. And then we just supply the text or the position here on x and the position on y. We're not gonna scale to y or center on y. You know, that could be done in a different thing, but for now I think it's easier if we just have this. No, not transform, it's font size, brother. And the text being black is also not what I want. Since we have a black background, we want it to be white. White's cooler. And so now we should just be able to draw a text centered. Using our kill counter. Position. And this is where I want to, I guess we do screen. Actually, I want to put it on 30 to 40 pixels. Maybe like, or let's say, I think maybe 40 pixels to the right and 30 pixels down. And then a font size of 20. And I think it wants a vector to initializer. Let's see if this works. It does. It's a bit far to the left, to the right I mean. But now we have the kills. And we can track this, which is cool. Now I thought it would be cool to quickly add some UI and some input to finish the actual game loop. Make enemy hits reduce the player size instead of insta-death. Oh, that would be a cool thing too, yeah. And the more kills we have, the bigger the player. That is actually a cool thing as well, yeah. Yeah, the game's taking shape, right? So you see how easy it is to make a game? It's really cool. I like this. It's so fun. Let's see. So, now that we have a really cool idea, and the idea from chat was actually to, instead of killing the player, we want to decrease the player size whenever we hit him. So, for example, over here, instead of just setting the game state to the default state, we can do game state, player size, minus equals 5 or something, right? And then if we have a game state player size of less than 0 or 0, then we want to set that to the default state. Which I think is a cool idea, because we also make it so that the player can become bigger by killing more enemies, which, you know, maybe that's a bit low though. I'm gonna try 10. I like difficult games, you know, I just like difficult games. And then we're going to quickly yoink the remove enemy part here. From the projectile. Where's that? We want to replace the enemy. There we go. Replace enemy with last. I don't want to type this again. Put this in the collision detection, which after we have decreased the player size, then we replace the enemy with last. And we do not need to break or anything. We just continue with the next enemy, which would work. Okay, now that we have this, we don't need to test it. It should work. I want to add one last thing. Very quickly, an enum game state, or a state, since we already have a game state. That would be in which state the game is. So for example, state, main menu, or a state, running level, or let's call it running, and then state, game over. These states, by default, I want to add that to the, and then this needs to be a type def, of course, because this is C. I want to add this to the game state, which by default will be the main menu. And we can also set this as the default state here. State is state main menu. Good. We're going to start in the main menu. And then all we need to do here is switch on the game state. We need to put this at the very top. We always want to draw, but over here we switch on the state. Game state.state. I've quickly coded in 3 sections. The running, the game over, and all of the other stuff. In running, we want to increase the game time and do basically everything we did. You can create a function out of this if you want to. I'm just going to take this code and copy it into this path here. So that is all of this code. We're going to put this in here. Paste. And then make sure that you select all of the code and indent that properly so that it looks good. There we go. Now that is the running part of the game. And if we start the game right now, we will be able to see a black screen because we are in the main menu. Now that we are in the main menu, we can do some, let's draw a center text. Let's say, well, bullet, hell. Let's draw that. Or let's say on the screen size or screen width, not screen height, width, divided by 2. And let's say an arbitrary number down of I don't know, 40 pixels. Let's test that. And then, of course, of a font size, this is going to be bigger. Let's try 100 or something. Now it should give us bullet hell. Hopefully it's centered. Okay, it looks like I did a mistake for bullet hell. Instead of minus, I did plus for the center text. Which, yeah, I did. So that needs to be minus. Then it should be somewhat centered. Yes, 100 is a bit much. Okay, let's do... I mean, 80 would be nice, I guess. And now that I think about it, I'm actually going to do bullet hell. I think that's fine. And then we draw one more text, which is press enter to start. And we'll put that also in the middle, but I don't know, let's say 200 pixels down. And this will be a font size of 20. There we go. Now we have basically a small little menu already. I love this, you know, this is awesome. Now you can see that it's not perfectly aligned, but for the first game, that doesn't matter. You know, you can try to align this perfectly if you want to, you know, fix this function. I think what's happening here is that it takes the first character and it's not drawing the first character around the middle. So you have to like do some measurements there. But for a first game, that's totally fine. And so now that we have this, we also need to add in some if key pressed. Is key pressed? Let's say key enter. Or is it return? I think it's enter or return. One of the two. Then we set the game state dot state to running. It's as simple as this. Now we are in running. And now the only thing we need to implement is the game state game over. What do we draw? And I'm going to yoink these two things here. Because it's literally just a copy of those two. We're gonna do, instead of bullet hell, we do defeat. And then press enter to, instead of start, we do restart. And then there's one more thing I wanna draw. And we already did this. I want to draw the kills. I wanna show the player how good the player was or how bad he was. You know, someone that only gets 50 kills. You're not good, bro. You know, I will probably get more kills than you, bro. And I'm terrible at games. Yes, sir. So we probably, let's see, we put this to... wait, font size is fine. Let's put this on 100. There's one last thing I forgot. Now that we have this here, we also need to set the game state to be over here. So instead of when we touch the player, the game's over, and you know the player size is less than 0, we don't do the default state here. We actually just set the game state dot state to be game over. State game over. And we do this whenever we actually initialize the game. So over here, when we set it to running, this is when we set it to the default state again. So this is where we reset. And we also reset this. We don't really need it. At the very top. Let me scroll up really quickly because we already have quite a lot of code over here. We set it to the default state, reset it essentially, and then we go to running. All right, now we should have a fully fledged game loop. Our very first game in Raylib. We can start the game. Why did it go back? Why did it go back? That's not supposed to happen. Oh, wait. I kill an enemy and then I switch over. I did a mistake here. Touch the player equals game over. Draw the enemy. Huh? Does this happen here? Eh? Am I stupid? Game state default state. What happened here? Huh? How did this get in here? What did I click? Lol? What? Okay, I'm sorry. I don't know why this happened. Huh? For some reason that was left in there or something? Okay. Alright. Let's see here. Now it should work. Sorry about this. There was some weird game state in there. Not sure where that comes from. So let's see here. Let's kill some stuff. Let's see how many kills we can get. We need to be very accurate with our mouse, you know. And as we get bigger, the enemies will get weaker. Because we have more projectiles. Just gonna... think spamming is the best thing to do. Spamming, guys. We need to spam. And our projectiles are going to get faster, more pierce, and stronger. Look at this. We're getting bigger. We're getting bigger. We need to kill these. Uh-oh. 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 We need to move. Oh, no. They eat a lot. Holy shit. But we have big projectiles. Here to the right. No. Okay, okay, okay. We get it. We can get it. Holy my, what happened there? Damn. Uh-oh. Oh, no. I can't spawn projectiles. This is the last thing we need to do. A projectile, when it's outside the screen, needs to go away. That's the last thing we need to do. And then we are done. And that is when we update the projectile. Before we draw it, we need to make sure that if the projectile, and this is a check collision boxes. We need to have 2 boxes, essentially. Or we could even do check point in a box. Collision point rect. So essentially we have our point, which is our projectile's position. And we need to have our screen rect. If we are no longer in there, then we also need to replace the projectile. And so over here, this is not the enemy. Where's the projectile? We need to replace the last projectile with this one. We need to replace this one with the last projectile. And so the screen rect is a const. Screen rect is essentially the size of it. Screen height dot width is screen width. And then X is 0 and Y is also 0. And we turn this into a const. There we go. And now when projectiles are outside of the screen, they will be removed, which will allow us to spawn as many projectiles as we want to. Okay, so this is actually the run. Let's see how far we can get. Okay. And if you can beat my high score, then you're good, because I'm actually good at these games, you know. I have very high mouse accuracy. Look at this. Yeah, we get this. Yeah, I'm already getting bigger. Look at this. Easy. 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 Oh, yeah. Look at me spawning more projectiles. No chance. Oh. Yep. No chance. Yep. Yeah. Oh! I didn't see that. It's fine. We still didn't lose. That's totally fine. 80 kills. We need to get over 100 minimum. Yeah. Easy. Wow, look at me spawning those projectiles there, bro. I'm a machine gun. Oh, no! Dude! Okay, I think I made the spawning of projectiles a little bit too much, bro. All right, I think we need to tone that down a little bit, because that's crazy. I can't lose anymore. Okay, I'm just... Oh, wow. All right. Okay, so that's a bit too much. So that's essentially the game. Now, we can, you know, tweak this a little bit with killing enemies and stuff like that. If you want to, you can also, you know, draw the texture whenever you're in game over screen, you know. I'm just not going to do that now. It's all there for you, and I'm going to upload this project to GitHub. And this is exactly what I did. I made a repository called My First Game. The link to that will be in the description. And I've also added a README on how to set up the project on Windows, where you have to download Visual Studio and CMake, and what steps to follow to set the project up for the first time. And then you can use it. Amazing game design. Yes, true. Yeah, I'm gonna keep it. It is how it is. It's fine. I think it's this shoot delay minus 0.05. We need to do something else here, like maybe 0.01 or something. So this is the game. And now this last section is for those who want to know how C++ works under the hood. We basically have built a game using Visual Studio, but we can also build a game using Visual Studio Code. And I have a portable version here where I only have the bare bones extensions installed. Yeah, C, basically the same. With, yeah, basically only 2 extensions, C++ and CMake Highlight. For those of you who like using CMake tools here, you can do this. But essentially what you need to do is, well, let's open a folder, right? So let's get the one in here, the desktop. My first game over here. Let me select that folder. And now we have our game C file here. that we can inspect. We already have CMake running, and we have the build folder running. And so if we now do our build command, which is CMake --build, it should build it, which it does. It does have some warnings here, which conversion, which I guess is fine. But yeah, we can build the game in here already. But I want to add 2 build scripts to this that allows us to invoke CMake using Control-Shift-B and then running it using F5. And so in order to speed this up a little bit, I have prepared a .vs code folder, which is usually what you would create by hand or using an extension like CMake. And I have a launch.json here, which in this case, it's just going to be game. That's what we have here. So that's running the game, which we should already be able to do this pressing F5. And yes, it is. It opens up here. Boom. We can play the game. Awesome. Now in the build script, tasks, this is where you can see the command for Windows, and we don't actually need that Windows specific command. This is just something I want to show you later. This is how you would localize the commands if you were to build using something else. So for example, Clang, you can see this is copied out here. And I'm gonna quickly go over this in a second how this works. But when we press Control-Shift-B now, it's going to call the CMake build, what we just typed in earlier. And then it will give us essentially the same result. And we can start and build now using Visual Studio Code. So if Visual Studio Code is something that you want to use, there you go. You just need, and by the way, these extensions, I didn't do anything. I just installed them. CMake Highlight, C++. The most bare bones extensions. I'm pretty sure most of you have their own setup for their extensions, but this is essentially what you would need to do using CMake and Visual Studio Code. Now, this is where it gets interesting. And you can see this already. We can use Zig to compile our game, and we can use Clang to compile our game. Clang is essentially a compiler for C++, and that is something that CMake uses under the hood. It's not using the Clang compiler. That's something that you can download, but it's using the Microsoft, the Visual Studio. It's used predominantly on Windows, and it's called MSVC CL compiler, like CL executable. That's a binary file that ships with Visual Studio when you install that. And Clang actually needs Visual Studio to work, which is why we needed to install that. On Linux, on Mac, Clang works out of the box. You download Clang. I don't know if it's actually installed or not, but you don't need to download a special library. And so in order to get Clang, I've also prepared a link, and I'm going to put all of those links for you guys to be used later. The download Visual Studio Code if you want to, and then the download Clang or LLVM. You can go to GitHub here on the releases page. This is essentially what it looks like. On the releases page, in another tab, we can choose which version of LLVM to download. And we have 62 and 32. We also need to do that for Railip later on, but we're going to use Win64 executable LLVM, download that. And oh wow, that's actually taking a while. Okay, so once this is finished, we're going to install it. I've already installed it, but we can do this again, it doesn't matter. There we go. So this is LLVM. I have already installed it. So LLVM is already installed. Do you want to uninstall? Yeah, I'm going to uninstall it. Just going to show you. It's not really a big deal to reinstall this. We can agree here. We make it so that LLVM gets added to the path for all users. We click next. Yeah, default directory. It's actually quite a bit of space. 2.6 gigabytes. That's crazy. And then we install. I guess I don't want to create a shortcut for LLVM. And then it installs. Okay, so LLVM now finished setting up. In order to test if it actually is in the path, we can call Clang here. And it actually does. I just want to quickly show you what the path means, because that could be confusing for someone. In Windows, you can edit environment variables, and then over here, the system variables or the user variables, there's always going to be a path variable. And this is where we want Clang to be. So for example, for me, you can see here that LLVM that we installed is added as a path here. The same for CMake and the same for Git. And so that allows you to then just call Clang, which is an executable, using the command line. And it tells us that there are no input files. So now with Clang, the way this works is we call Clang and then we give it some input file like a game.c file. So for example, we are in my first game and we can give it a game.c file here, game.c, and then it's trying to compile that game.c file. Now, it will tell us that it can't find raylib because we didn't tell this command line where to find raylib. Remember in the very beginning when we set up CMake, how we needed to download raylib? Well, we have it actually, but we just don't know, or the command line Clang doesn't know where it is. It is actually inbuilt under dependencies. And this is where we can see the raylib build. So we're going to do now by hand what this CMake file did for us automatically. We're going to download raylib for Windows. I've already prepared a link as well. Under raylib releases, we can download raylib version 5.5. And when we scroll down here, there's a bunch of changes. We can see the different versions. And so what we can see here, and I talked about this earlier, we just downloaded Clang. That's a compiler. And we also have different versions for Windows. You can see here, MinGW, by the way, is another compiler to not make this too difficult. So we're just going to download the MSVC version. We want to download the raylib 5.5 Win64 MSVC package. Once we have done that, we get a zip file, and if we extract that zip file, we get this. We get an include and library folder, and then also changelog and license, but these are not important. In the library folder, we get a raylib DLL for dynamic linking. I'm not going to go over what exactly that means, but it's more or less linking when you're running the code, not statically, so not built into the executable. And we also get a raylib.lib file. This one is actually used if we want to statically link our executable to raylib, and this is what we want. And then in the include folder, we have the raylib header file, the raylib path, and the raylib.gl.header. These will be needed as well. And so we take those two folders and then copy them into our My Game folder. So back in the folder here, we create a new folder called third party. And then in that folder, we're going to paste the lib and include folders, which will from now on function as our library folder. So if we want to add another library, we're going to include the lib if it has a lib, and we're going to include the header files if it has header files in the include folder. And so now that we have set this up, we can start Visual Studio Code again. We left off with the CMake command, and what we need to do now is add in our own commands so that we can use Clang. And what that looks like is the following. We invoke Clang, and then we put the game.c file as an input file. If we were to do this right now and rebuild, we're gonna get an error because it can't find raylib. And this is our task. We need to tell Clang where to find raylib. And we do this by, for example, giving it the linking or the inclusion parameters. So for example, -I stands for include directories, which is the directory that it looks for header files. And so that would be third party /include. Now it will find raylib, but we get a bunch of unresolved external symbols. These are basically symbols or functions that we need to link against. And that means the function definitions are there, but the implementations are not there. And so in order to get that, we need to do a -L, capital L, which stands for linking directory. And then we supply the third party again, but this time the .lib folder. And then we need to -L link the raylib. When we run this now, we still get a bunch of unresolved external symbols. And this is the problem of basically compiling on a certain platform. When you use something like raylib, raylib interfaces with the Windows operating system, and the Windows operating system has a bunch of their own libraries. So these would be, for example, and you can see them down here, the user32, the shell 32, GDI32, MSVCRT, WinM. I don't even know what these do myself, but it's the fact that we need them for raylib, because raylib is opening up a window, it's interfacing with sound, it's gathering input. All of this stuff needs to be handled by raylib, and raylib can only do that if it can talk to the operating system. And so the way this works is that this third-party lib folder is basically a folder that Clang looks into to find libraries. By default, Windows has their library stored in Win32. If we take a look at this path, we have C Windows System 32. This is where we can find the Windows libraries. So for example, take a look at GDI32. That is a DLL that we are loading in our Clang call. And this can be found here. So Windows by default stores all of their libraries in the Windows folder, the System32 folder, and in order to have a custom folder for our own libs, for example the raylib.lib file, which can be found here, we need to tell the compiler where to find it, and that's what we're doing with this command. And so now I'm gonna complete the commands so that it works, but essentially this is why CMake is oftentimes used to abstract this away, because the libraries that implement the CMakeList file themselves, they will handle this stuff for you. You don't have to worry about that for the most part. So in order to complete that, that would be -l user32, -l shell32. Let's move this to the right a little bit, then -l GDI32, then -l MSVCRT, and then -l winmm, and at the end a no std lib. This option right here, if we don't submit that, I can show you, we're not going to get any linker errors, but we're getting a warning that the default libcmt conflicts with the use of other libs. And then it tells us what to use here, the no default lib. That's essentially the way that raylib is built. We have no control over this unless we build raylib ourselves, which is an entirely different story. And you can see why C++ build systems are the way they are. They are really annoying. So essentially, we just need to add the no std lib command here, and then that will get rid of the error. And now we can compile our game and run it too. There you go, that works. And then it just gives us a warning, and the game should now be built. We have a linker warning and we have a bunch of other warnings because it says we are passing a const char parameter to a char pointer, which discards the qualifier. So I guess I forgot. And this is why I like this more, by the way. You can see here, if we switch over to the CMake build, it's actually hiding these errors. You see here that it will just work. And so this is why I like this command a bit more, the clang command, because it will always give us these warnings. So we're dropping the const qualifier, so it's complaining about this right here. Well, we could just say then that's a character array. And then over here, that's also a character array, right? Fixing it like that. It's not the best way to fix it. And then that's it. Oh yeah, so now that I have the full command, it's actually no std lib, and then you can see here that this command is very long, and that's why CMake is just a faster option if you want to get started. And you can ship a full game with this. You don't have to do it this way. Just wanted to add this in because I think it's great to know what C++ is doing and why something like CMake can be great to use. I don't like it too much. I like this more. I like being specific. I told you about the errors, the warnings, and so I like this more. It's preference. And then I want to show you a little trick now at the end. You can also use Zig, which is really cool, to build your game. And I've actually already prepared a command. You can see here that Zig has a C or C++ compiler built in. And we basically do the same thing. We link third library lib, we link raylib, then user32. These are the Windows libraries. And then we also include, well, the folder, the include folder for the third party, for the library. And then we output a game executable from the game.c file. And, well, how do you get this? How do we get there? You can see here that I have prepared a command for Zig. The cool thing is we just need to download it, and then it works. I've already done this. If you want to get Zig yourself, or maybe you already have it yourself, here's the website, and I'm gonna link that in the description, just like all of the other links that you might need or want. And you can go to the releases master and then download your file for Windows. So that would be the x86-64. You download that zip file, and once it's done downloading, you can extract it. I have already done this. It is for me on local C, and then Zig over here. You should add it to your system path. Again, that is the path variable. I've added that to the system variables, not the user variables. You can see here that Zig is right here. So I've added it to the system path, which means I can call the Zig executable to compile programs. And the cool thing is we can actually compile C++ programs with this. You can see here the command, and let me comment this out. The Zig command. CC stands for compiling with C. And then we can also do C++ as far as I remember. Yes, it does. And so I can compile either with C++ or C to compile my game. And it just works. I've just done it. There are no errors. I can run it and the game still runs. So if you want to have a very fast build system, all you need to do essentially is download the Zig, download yourself a library that you want to use, or maybe use Windows directly, and then hack away. So that is actually the fastest way. You don't need, and this is the important part, you don't even need Visual Studio. Visual Studio is needed when you're using something like CMake or Clang. They all depend on this. Zig, on the other hand, does not. You can just download a very small package in Zig, use that to make your games, and you're totally fine until Zig changes. But you can always use the same version of Zig and never update, which in my opinion is really cool. You might have to restart Visual Studio Code if you do so. So if you don't have Zig available to you here, then you might have to restart Visual Studio for this. And then you can invoke this command, and this will all be available, by the way, on GitHub. If you don't want to type all of this, I'm going to put all of this on GitHub and instructions on how to download these things and stuff, where to find them. I've now built the game using Zig and I can run it too. It's actually quite funny. So the fastest possible way actually to get started on C++ is to download Zig. Because Zig is only 200 megabytes big. Let's see here. How big is this? Yeah, like 300 megabytes. You download Zig. You open up Visual Studio Code. You paste in this command. Well, obviously you also have to download Raylib, right? That takes some time. And then you can make a C file or game CPP file, whatever you want to do. And then you have your game. But yeah, so that's the tutorial. Hopefully this is helpful for someone. This is essentially how from start to finish you can make a game. And now you can put this game into a zip file and upload it to itch.io. Your first game. Boom. Done. I think this is something that if you want to get started in C++, it's a great way. Where's the game? The game's here. This is the game. Bullet Hell. Yeah. And now have fun making games. Hopefully this is helpful and you can start making games in C++ or give it a try if you like C++ or not. This is hopefully the easiest way to get started. No long tutorial that takes 20 fucking episodes to get started. Full game in one episode, essentially.